So to talk about the day in the life of a data scientist, really there's these kind of 4 steps. So you start on the left, and one of the things that I find most important is to a little bit think before you jump into code. So plan ahead a little bit. So you kind of want to know what question you're going to solve. Okay, so you can solve a lot of these data analysis. You can do it in a lot of different ways. So it's really important to understand, okay, this is the question I'm going to solve for, and what's the data that I'm going to use for this? A lot of times you want to have this data, but you might not have access to it, or you don't have it. You have to collect it first. So after you go through that, you go and you do acquire the data that you need and make sure it's there. And one of the things that Hadoop helps a lot is because a lot of ingest happens for you. As a data scientist, one of the things I love about Hadoop is that I just have to have access, and usually all the data is already there in the data lake. After that, you go and you clean up the data. So the cleanup is really a lot of data comes in from 100 different sources. So you got to do normalization. You got to impute missing values sometimes, fix some normalize the data different ways. And it's a very iterative process as well, as shown in the slide. So you do some work, and then you check it again, and you do it again. After you finish this, you go to the analyze phase. That's where most of the machine learning stuff happens. And first, you kind of create your features for your model. That requires also a lot of data engineering and data munging. You create your model, whether you use random forest or logistic regression or whatever model you want to use. And then you evaluate your results. And you say, OK, is this good enough or not? And usually in iteration 1, it's not. So you kind of do it again, and you add more features. And sometimes you go back to clean up the data because the reason it wasn't good is because the data was not good. So all of this is iterative, inside each of the boxes, but also in between the boxes. So it's kind of a mess, and that's kind of how life is. What I'm going to show in the demo is kind of the result of, I'm not going to show you all the mess. I'm going to show the result of when it works. But you got to realize that underneath it, there's a lot of stuff that's going on in real time. When you're done, when you're really done and you did all the iterations, then you publish it like I'm going to show you in an IPython notebook, where you show all the steps that you went through. Sometimes you want to publish it and send it to another colleague, somebody that you can take a look at it and give you comments. Sometimes you do a report to your boss, or if it's really ready and you want to productionize it, then you take the next step to put it into production. All right, so now let me move to the demo, and that will be, let's see, I can look here, I guess. OK, that's easier. So I'm going to go to the IPython demo, and I'm going to make it a little bit smaller here. Sorry. All right. So in this demo, I'm going to make it a little bit smaller and shrink the size here. All right. So what I did in this demo is really, I was interested. There is a data set that the city of San Francisco publishes, which is a crime event data set. Actually, a lot of cities have that. But I took the one from San Francisco and already uploaded it into Hive, so we can have easy access to it. And I wanted to explore this data set. And one of the things that wasn't there, so the data set has a lot of different fields. One of the things it doesn't have is the neighborhood. It has districts and things like that. Now, to do the neighborhood analysis, I wanted to add a neighborhood to each one of those fields. Now, that required some geospatial analysis, which I did offline. The reason I did offline and not in this thing, because it's a small query, but it takes about 10 minutes to run in Spark SQL. So I kind of didn't want you guys to wait for 10 minutes. So I already created a data set that has the neighborhood information. And so in order to run this, in this first cell, I just create the Spark SQL, the Spark context. As you can see here, I import the pandas, which I'm going to use as a Python library. I create a Spark context. I generate 6 executors with 8 gigabytes each and run it on Yarn. And this is also generating the Hive context, so I can access Hive. All right? And then I'm going to run this thing. This is a special, the Spark context is already ready, so I'm not going to execute that cell. But here, what I do is I want to explore this data set a little bit. So I'm clicking on this. I'm running this two things in Spark here. One is just counting the number of crimes, and then counting the numbers of crimes that were resolved. And as you can see, I got the results, about 1.75 million crimes total in this data set, and about 700,000 were resolved, roughly half, a little bit less than half. Just to show you also, here's what the data set really looks like, right? So you got category, description, district, date, time, day of the week, resolution, a bunch of different fields like that. Okay, so that's this data set. Now, what I want to do is I want to extract and do some basic feature extraction or feature generation. So again, this is a simple demo, but what I do is I thought that, the year is an interesting thing to look at. We also need it for filtering later on. As a feature, the month is interesting because some months maybe it's raining and there'll be less crimes or less likely to resolve by the police because they're sitting more inside or whatever. The hour of the day might be interesting in terms of whether a crime gets resolved or not because it maybe requires to be resolved the next day. The other thing I do here is I transform the resolution. The resolution is a string. It's got all kinds of different types of resolution it can have. None means it's not been resolved. So I actually distinguish that as my target variable. So my resolved variable here will be 0 if it wasn't resolved and 1 if it was resolved, any other string. And then I take the other variables. I have all kinds of strings like the category of the crime, the district, the day of the week, the description, which we'll talk about later, and the neighborhood, which I had previously. So this is what this data set looks like when you have all these variables. It's a little bit different because we have different fields here. So actually, I can run this too. I was talking about this, but I can run this really quickly so you can see this is generated relatively quickly. And this is, again, this is my Hive context. It's a Spark SQL context that can communicate with Hive, and so you can write this as a simple Hive query. So once I got that, the next thing I want to say is I want to ask a question is like, how likely is it from historical data that a crime gets resolved per neighborhood, right? So this is an interesting question. And so what I do is, again, I use Hive data frames API. First, I group it by neighborhood, and then I calculate the likelihood to be resolved, essentially as summing up, computing the average, because my resolved is 0 or 1. So if I kind of do an average, I actually get the probability of a crime being resolved per neighborhood. Similarly, I can count it just to see the number of crimes total. And what I get is I get a pandas data frame here, which looks like this. So per neighborhood, and I just printed the first 10, with the probability and the count, and that's what you see here. And of course, similarly, you can visualize this. So pandas has a very nice plotting function, so you can just set to the style of similar to ggplot and plot the likelihood to be resolved. And so we can see we have Civic Center is kind of the top one, and then we got the Mission District and Bayview and things like that. So that's nice. And now the last thing I want to do in kind of showing you a little bit of the exploration is there's a nice library in Python called Folium, which is kind of early stage, but it's really nice because you can plot interactive leaflet maps that work interactively. And within IPython, it's really nice. So what I do here is I have a little function that embeds this map inside a IPython notebook. And what I do is I plot the map. Let me run this actually for you. So again, it's really quickly. It generates a map. And the map is also kind of color-coded by the percentage of the likelihood to have a resolution. And it's kind of going onto the side, so you can't see the legend, unfortunately, in this screen size. Maybe if I make it smaller. OK, here we go. So it shows a little bit better here. But this is, it kind of color codes the percentages, and it color codes it. And you can see the polygons in the neighborhood. And within each, you have a color coding of that percentage. So that's kind of, a little bit exploring the question of, how much, how crimes are looking historically. That's usually what we do with BI. Now I want to move to more predictive stuff. OK, so we want to do machine learning. And again, Spark has a machine learning library, which is pretty cool, which is one I want to show you next. So can we predict, the question I'm asking is, can we predict whether a crime, I have a crime event, can we predict whether it gets resolved or not? OK, that's an interesting question. And so always the question is, do we have the right features? But here I'm going to show you that with these really simple features, we can actually do that in a really nice way. So going through the code again here, I create a train data set. And for this, I took the original data set, which has crimes between, I think, 2003 and 2015, and filtering it down to a training set that's a little smaller, about 3 years, 2011 to 13. And then my test set, where I'm going to measure the results of my model's performance, I'm going to take it for the year 2014. 2015 didn't have enough all the years, so I kind of left it with 2014. So as we can see, the data set sizes is about 420,000 or so training instances, and then about 150,000 testing instances. For convenience, I created this function in Python that computes some of the metrics I'm interested in for classification, precision, recall, accuracy, and things like that. And now I'm going to use the new pipeline API that Spark machine learning library has. And what I'm doing here, and I created this diagram to explain it a little bit better, is you take the data frame that you have that's distributed on a cluster, and you can do a lot of transformations to it. So what I need to do here to make it work is all the strings that I have, category, district, they're all strings. And SparkML doesn't take them natively. So I'm first translating those into an index. So I have, there's a string indexer here, which takes and counts how many strings there are, and translates into a 0 to n sort of, n-1 sort of value in a different column. So I specify the input column and what I will call the output column. And I do this for all these string variables, day of week, district, neighborhood, and resolved. Also the label, this is the label of what I'm going to predict. The other thing I'm doing is I'm taking, and this is actually interesting, the description of the crime is kind of a text field. So it's not a long text field, it's like a tweet. I mean, it's what the police people put in there. But what I'm doing here is I'm actually taking another interesting feature generation feature of SparkML, which is called a tokenizer, which takes this and breaks it into words, and then taking the words, and I'm using a hashing function to create a fixed number of features there. Putting it all together with a vector assembler, putting it all together in one feature vector for my model. And then here, generating the random forest classifier, generating my pipeline in this line here, just creating all this pipeline as one pipeline. And when you generate your model, these are the two lines that are important. One is you train your model. So as you can see, I take the training data, and I'm creating the model. And the result is transforming of this thing, OK? And the result will be a set of predictions, ones or zero, whether it's been resolved or not. And then I'm calculating my prediction just to show you. We'll run this guy. This takes a little bit of time, a little bit more than a few seconds, just because I'm running 100 trees in my random forest here. So it's running on the cluster on Spark, and it'll show me the results in a second. Let's wait for that. And this cluster is kind of relatively small. I have about 6 executors with 8 gigabytes, so it's not a 100-node cluster or anything like that. While this is running, I'll show you this in a second. While this is running, let me explain what happens here. The last thing I want to do is I actually want to show what I'm going to get from above is I'm going to get a precision, a recall, and an accuracy number for my overall model. But I also wanted to check what that looks like for each individual neighborhood. And I wanted to present it in a visually compelling way. So first, I'm creating a representation of the centroid of each neighborhood, the central point, longitude and latitude from the polygon. So I'm using a nice little Hive UDF that does that. Let's see if this finished. OK, so this finished. So we see about 83.8% precision, 62 recall, and an accuracy overall of about 82%. So that's pretty good numbers. And then where's my mouse? OK, here we go. So then I'm creating this. I'm doing a Hive query that essentially says, given neighborhood, give me the longitude and latitude of that neighborhood, the central point in that polygon, running that. And then it's a data frame. And then what I'm doing is I'm creating another map here. Let me run this. And this map is essentially is the same map we've seen before of San Francisco. But within each neighborhood, I'm going to have a marker that shows the accuracy localized to that neighborhood. So if I look at this map, but this map is really nice. I mean, you can kind of move it around and make it smaller or larger or anything like that. But here I can click on this guy, for example, and it shows, OK, this is Golden Gate Park, and the accuracy of the model here is pretty large. I can really predict whether something will be resolved or not. If I go to this guy, for example, it's the Bayview area, and it's 78. 78 is not bad, but it's it's still pretty good. So that's my demo, short, and I'll turn it back to Vinay.
Thanks, Ofer. So, so in this demo, we saw a day in life of a data scientist. We saw Ofer importing some data, exploring the data. The data was all there in the data lake, so it made the exploration part easier. He went through a question in his mind whether the crime can be predicted based on where the neighborhood, and based on the model, he trained the data, and based on the training set, he ran against the test data and predicted what is the likelihood of a crime getting resolved based on a particular, whether it's what type of crime it is and what neighborhood the crime happened in. So that's the day in the life of data science. Because this talk is about Zeppelin as well, let's talk about how Apache Zeppelin can solve the same problem and is a new tool in the arsenal of a data scientist. So we'll go through
Here we go. I'll
okay.
use this guy.
So we'll introduce Apache Zeppelin, and we'll talk about what Apache Zeppelin provides and why we are so excited about Apache Zeppelin. So what is Apache Zeppelin? You saw IPython notebook. Apache Zeppelin is a new notebook. It's based in Java architecture. It's implemented with Spark and Hadoop. It supports multiple language backends, and we'll see a demo of many of those features. And it's a new project that we are excited about, and it's in incubation in the Apache community. What use cases Zeppelin supports? It supports data exploration, discovery of data. So as a data scientist, you want to know what data is available. You're exploring that. You just want to do some visualizations, see some graphs, charts, etc. It provides that. You don't have to, unlike IPython, you don't have to bring in a matplotlib or any other dependencies. Those are built-in features. And you can run nodes or snippets of code at a time. And it also facilitates collaboration and publishing. In essence, it's a modern data science studio in Apache community. So let's see a day in the life of a data scientist with Apache Zeppelin.
Can you switch it back? All right, there you go.
Hi, I would like to start from loading data.
It was good. Yeah, I did good.
So how many people here heard about Apache Zeppelin? Yeah, thank you. Yeah. So I'm going to make a quick demo of Apache Zeppelin, how it helps data science workflow. And this is really simple demo. So if you once you see, you can compare what is difference from IPython notebook and what is the advantage of Apache Zeppelin. And I'd like to really appreciate if once you guys can contribute to Apache Zeppelin. Okay, I think I can start demo from loading data. This is a very small, simple CSV data for the demo. And once I have data, I might want to explore the data. So I can use some Spark API or some, I don't know, some APIs. But in Zeppelin, it provides some useful utility to explore data. So the first thing is Zeppelin have a display function for the data frame of Spark. So once you have data frame, then you can display the data frame in a table. So the data, this example is customers of the bank. So it's the age of customers and their job and marital status and education and balances of the customers. And once you have data, then you might want to make some kind of visualization. So Zeppelin have a built-in visualization, and it's got some simple chart, like a bar chart. And it also have got a pivot function built-in. So you can play around your data with a simple drag and drop interface, pivoting your data like this. And not only data frame, but Spark SQL also visualize inside of Zeppelin. So if I'm writing one simple SQL, like I'd like to know how many people per their jobs, then I could like a simple query like this. And then it visualizes in pie chart. And yeah, in this moment, I maybe wanted to work with my coworkers so I can look into the data together. Then I can just share the notebook URL. Then he will see the same page in his web browser. And then what I do is here. What I do is synchronize in his browser, so I can collaborate with the other workers. And maybe this looks good for this. Let's say this gives enough insights over the data. Then I maybe probably change some layout to show this notebook to my boss. And I can change the theme to a simpler one, like reports. Then it hides all the code and text output. So I can directly share this URL to my boss. And then maybe in next 10 minutes, my boss will come call me and can you change this? And can you, my boss will keep asking every 10 minutes about changing, the chart. So Zeppelin can have that situation. So let's say my boss wanted to change the minimum age of the query here. So if my boss wanted to keep changing the minimum age, then I can create a input form dynamically, so he can change himself, like inside of a report. Yeah, he can change himself, like putting numbers here. So it saves a lot of time. So yeah, this is I think a basic workflow with Zeppelin in your data science work.
Thanks, Moon. So, what? So, we're not done with the demos yet. So you'll hear more from Moon in a few minutes. But so just to recap what we saw, unlike IPython, you didn't need to import Spark context. The Spark integration is built into Zeppelin. There is no need to add any dependency for visualization. There is forms, and it also supports third-party dependencies. So let's talk about why Zeppelin is so good in terms of architecture and how it integrates automatically with Spark. So we'll dive deeper into another demo from Moon, where we'll talk about what is the architecture for Zeppelin, what different backend, because if you'll see the Zeppelin architecture demo, you'll see that Zeppelin supports multiple languages and backend. So it supports Scala, it supports PySpark, it supports Hive, it supports Spark SQL, it supports Tajo, Flink, and so on and so on. And the reason for it being able to support so many different backend is because its architecture is pretty extensible. And as we'll see, there is interpreter group and interpreters which are isolated. So Moon, why don't you show us more of your demo?
Okay. As you saw in previous demo, I didn't create any Spark context, or I didn't create any configuration. Zeppelin does automatically inject Spark context for you, and I'm going to show you how you can configure these functions. And once you go to interpreter menu, then you will see profiles of your interpreters. That's configuration of your interpreters. So right now I have created two different interpreter profile for Spark. One is a production cluster and the other is test cluster. And if you wanted to create a new one, then you just click create and select the backend you wanted to add. Then there is some configuration you can configure. And once you have this profile, then you can bind your profile into your notebook. So in your notebook, you can select which profile you wanted to use. So for now, I'm using test cluster. And if I wanted to switch to production cluster, then I can just select this one, and then run the same code, and it will run on the production cluster. So in this way, you will able to use Zeppelin with multiple different cluster, not only Spark cluster, but also different cluster to different backend too.
Cool. So this is a really cool feature where we saw that the same Zeppelin notebook, you can run some notebook samples against your test cluster, where you have, when you're satisfied with the result, if you have more data in another cluster, you can point to another cluster through some configuration, and you just map, you just maintain the mapping of notebook to whatever cluster it's pointing to. And so this slide talks about the architecture of Zeppelin, why it's so extensible. So Moon, why don't you talk us through this architecture and tell us why?
Zeppelin has pluggable backend architecture. So it's got something called the interpreter group, And interpreter group is a kind of a sandbox for the interpreter. And interpreter group runs in separate JVM process and it communicates with the Zeppelin servers. And inside of interpreter group, there can be multiple interpreter implementation, and the interpreter implementation that is a connector between Zeppelin and the backend. And for example, Spark interpreter group have multiple interpreter, including Spark and PySpark and Spark SQL and dependency loading interpreter. So inside of interpreter, because it's running in the same process, it can share the resources. So for now, same Spark context is shared across Scala and PySpark and SQL interpreter. So yeah, it really helps create new backend, integrate new backend into the Zeppelin. Zeppelin.
Thanks, Moon. So to elaborate, because with Zeppelin, the interpreter groups is the container under which different interpreters are, and different interpreters which are part of the same group can share data among themselves. So what we're not showing just yet, because we'll have to switch the laptop again, but please swing by at the Zeppelin demo pod in the Hadoop Cafe that we have, and we'll go without any audio, video issues, all the demo details. So you can see, you can have two windows of notebook open side by side between PySpark and Scala shell, and you can share variables data in between that. So also, we touched upon this. So this is how a notebook can point to various clusters, because you basically have an interpreter that's pointing to different clusters, and you can map the notebook to the interpreter mapping. So we'll skip the interpreter deep dive because we only have a couple of minutes left for Q&A. And for more demos, please swing by at the Hadoop Cafe. The call to action that I want to leave you guys with, it's an Apache community. So we want you guys to, if you can spend some time trying out Zeppelin, joining the project. Maybe you can suggest certain enhancements, or if you're a developer, you can add some code. It's a young community, and we are very excited to be part of this. Questions?
So is the intention of this to basically be an IDE for Spark development? Why should I use this versus something else? All the other visualization tools that are available.
So the question is the intention for this to be an IDE for Spark development? And why should I use this tool versus some other tool? So this tool is great, but to call it an IDE might be going too far. Like, I am a developer, and as an IDE, you get code completion, you get syntax highlighting and all that. An IDE is where you will write many pages of program, and nobody calls it pages of program, but you'll write big programs. Here you'll write code snippets. So essentially, think of it as a Scratchpad. If you're, without this notebook type experience, you will be at the command line in either Spark Shell or PySpark. So as a replacement for that, plus the sharing, the notebook capability is what, where you'll use it. So as a data worker, it need not be just a data scientist, but as a data worker, if you are exploring some data, seeing what's there, versus in an IDE. So as a data scientist, you'll create a model, you'll see what data, and if you decide that that becomes a job that needs to run in your production cluster, that perhaps you write that job as a product using an IDE. Yeah, so the question is, can you give some information about Zeppelin Hub? Is it related product?
Yes. Zeppelin Hub is a related product, and it enables sharing notebook to team, and gives access control for the notebook. Yeah.
So in Apache community, Spark 1.4 was released last night this morning. So with that, Spark R is one of the new alpha features of it. And
Yeah, Zeppelin community is definitely going to have a support for R, but for now we are focusing more on basic features, but next step is definitely going to have more support on Spark, Python and R.
so we have 10 seconds left. I want to thank you guys for coming in here. I want to thank you the guys in the audio video for helping us through get this. And I apologize we came in here late, so we brought it upon yourself. Thank you.